In this section, we are going to be learning how to calculate with moles. And to do that, we're going to use our mole map. Using the mole map that you have on your screen, we can go to mass, volume, or representative particles. We'll start by looking at mass. Mass is measured in grams. And in order to get to mass or from mass to moles, you are going to use the molar mass. And the molar mass comes from the periodic table. If you are looking to go to volume, volume is measured in liters. And if you wanted to go from moles to volume, or from volume to moles, you are going to use the ratio that there are 22.4 liters in 1 mole. This is true for 1 mole of gas at STP, which is standard temperature and pressure. And the last thing that we'll be working with is representative particles. Representative particles could be atoms, molecules, or formula units. And to go from moles to representative particles, or from representative particles back to moles, we are going to know that there are 6.02 times 10 to the 23rd representative particles in 1 mole. So therefore there are 6.02 times 10 to the 23rd atoms, molecules, or formula units in 1 mole. The last thing that you may want to go to is look at subatomic particles, atoms, or ions, and that would be right from here. So if you wanted to go to atoms or ions, specific atoms within a compound, you're going to look at subscripts. On the next couple of slides, I'm going to do a problem with mass, volume, and representative particles, always referring back to this mole map. There'll be a picture of the mole map available to you on Google Classroom as well. The first example that we're going to do is a mass example. Our question is going to read, what is the mass of 2.1 moles of water molecules? First thing that we need to know is what is the molar mass of a water molecule? Water, being H2O, is going to be made up of 2 hydrogen, which each have a molar mass of 1.008, and 1 oxygen, which has a molar mass of 15.999. When we add them together, our molar mass is going to be 18.015, and that's grams in 1 mole. So now we start with our problem, and we have 2.1 moles of water. We're going to set that up, put that over 1. Our moles is on the top here, so it's going to be on the bottom here. And because I know I'm going from moles to grams, going back to my mole map, I know that I'm going to use the molar mass. So we're going to put grams on the top, and it's going to be 18.015 grams in 1 mole. And when you do that, your answer is going to come out to be 36 grams of water. In the second example, we have how many moles are in 13 grams of carbon monoxide. Because we're going from moles to grams, again, I know that I'm going to need the molar mass of carbon monoxide. so CO. When I look on my periodic table, I'm going to add the molar mass of carbon with the molar mass of oxygen, and that will be equal to 28.01 grams per mole. So when I set up my problem here, I have 13 grams of carbon monoxide. Going to put that over 1. Grams on the moles on the top, 28.01 grams in the 1 mole. When you do out your math, you're going to have an answer of 0.46 moles of carbon monoxide because your grams is canceled and you are left with moles. Our next set of examples will be about volume. And our first question, what volume would be occupied by 4.75 moles of methane CH4 gas at standard conditions? We know, going back to our mole map, that there are 22.4 liters of any gas at standard conditions in 1 mole. So we're going to set this up that we have 4.75 moles of CH4. Put that over 1. Moles is on the top, so moles will be on the bottom. And there are 22.4 liters in 1 mole, so our answer should become 106 liters of CH4. Our next example, how many moles are present in 19.4 liters of CO2 gas at standard conditions? We're going to start out with our 19.4 liters of carbon dioxide. Liters will go on the bottom. We can go from liters to mole because this is gas at standard condition. There are 22.4 liters in 1 mole of gas, and you should get 0.866 moles of CO2. Our next set of examples will be about the representative particles. Example 1, how many atoms of neon are in 3.8 moles? If we went back to our mole map, we would see that there are 6.02 times 10 to the 23rd atoms in 1 mole. So when we do this, we're going to start with our 3.8 moles of neon. And we know that there are 6.02 times 10 to the 23rd atoms in 1 mole. When you do that, you are then going to have 2.3 times 10 to the 24th atoms of neon. Our second example, how many moles of water are in 7.4 times 10 to the 24th molecules? Going back to our mole map, again, we know that there are 6.02 times 10 to the 23rd molecules in 1 mole. So we're going to start this by writing 7.4 times 10 to the 24th molecules. Molecules to moles, and there are 6.02 times 10 to the 23rd molecules in 1 mole, and when you do that out, you will get 12 moles of water. Our final example with representative particles says how many ions of sodium would be present in 3.1 moles of sodium sulfide. If the formula was not already written, you would need the formula here, and you're going to start off with your 3.1 moles of sodium sulfide, and you're going to first go from moles to formula units. And you're going to formula units because this is an ionic compound. And we know there are 6.02 times 10 to the 23rd formula units in 1 mole by using our mole map. To get the number of ions present, we know that there are 2 sodium ions in 1 formula unit of Na2S. And I know that by looking right at the subscript. Moles would cancel, formula units would cancel, and you would be left with ions of sodium, which is what it's asking. And when you do this out, your final answer is going to be 3.7 times 10 to the 24th sodium ions. In the last problem that we're going to do, this is a 2-step problem. And it asks us how many formula units are there in 38.74 grams of sodium chloride. We know that if we go from grams and we want to end at formula units, looking at our mole map, there's no way to go directly from grams to formula units. So we need to go to moles first. To go from grams to mole, we're going to use the molar mass, and to go from moles to formula units, we're going to use 6.02 times 10 to the 23rd. So we start off with 38.74 grams of NaCl. We're first going to go from grams to mole, and we're going to use the molar mass of 58.44 grams in 1 mole. At this point, we would have moles of NaCl. But we don't want moles of NaCl, we want formula units. And there would be 6.02 times 10 to the 23rd formula units in 1 mole of NaCl. At this point here, grams would be canceled, moles would be canceled, and you would be left with formula units, which is what it is asking for in the problem. And when you do this, your final answer should be 3.991 times 10 to the 23rd formula units of NaCl.